manual transaxle basics. Make sure you have an answer sheet. There will be a test. And you'll know when you're supposed to fill out your answer sheet. And don't act like no second-rate amateur. And if you have your phone out, it's instant termination, just like at Walmart Distribution Center. All right, we're good. These guys, I guess, are going to get pencils. They'll be back in a minute. The purpose of the manual transaxle, with all the drivetrain components that are good, that's it, he fired you out. And spreads from front to rear. They're littler, they're smaller, lighter, but they still have enough room. You don't have to have a transmission tunnel if you got front wheel drive, right? And so, or if you've got everything in the back. If the engine's in the back or the transmission's in the front, you don't have to have a tunnel. Now, most of them got a console anyway, you know what I'm saying? But the majority of family cars are front wheel drive now. They Transaxle have the differential in them. We've been talking about that before. That's not really all that complicated, right? Okay, manual transaxle can be divided into two sections. You got the transmission section, and then you got the differential. That's why they call it a transaxle. I mean, you know, you're on the earlier ones, like the earlier front wheel drive ones, like Toronados and Eldorados and stuff like that I used to have to work on. They actually had a little cast iron housing with the differential in it, and because the engine sat in those cars straight, it didn't sit sideways, and they have to do things a little bit different way when they do that. Now the Acura Vigor actually had the transmission, the engine was in there straight, and the transmission looked like a regular transmission, except that the output shaft, instead of going back to a drive shaft, came back out the front into a little differential assembly. And if you're ever taking one of those apart and putting it back in there, you need to put a lot of grease in there around those splines where that transmission hooks into the differential, or it will wear out those splines. Seen that happen. Anyway, the transmission section uses the same kind of components as a manual transmission. Now this is manual now, not automatic. Shift fork, synchronizers, gears, basically the same design. There's one major difference. There's no counter shaft on a manual transaxle.
I remember that from last semester. I learned that.
Yeah, that's right. No counter shaft on a manual transaxle. This right here would be your standard, you know, and then you got a counter shaft down here on that other one. Now, you got the counter shaft not necessary because rotation from the input shaft to the main shaft, called the output shaft, is transferred to the differential by way of the ring gear, which is built right into here. Now, remember when I was talking about the automatic transmissions on the Toyota Camrys and stuff, you need to make sure that you understand that, and I don't know when that changed, but anyway, you need to make sure that if you're working on a 90s Toyota Camry, or sometimes maybe even to the early 2000s, the differential part of it is a different oil chamber than the rest of the transmission. And if you don't check it, you know, it could lock up going down the road, and that'd be nasty in traffic in Atlanta. Rear wheel drive transmissions like this, you got a main shaft, you got your counter shaft right there. This right here is, see, this goes out to your CV axle. That's coming from the transmission itself. Now, the differential is built in from the gears, you know, from actually, this is the output of the manual transaxle, front wheel drive differential, and this is going to your wheels. And here's your rear wheel drive. So you got it set up, it's going back here, and then it goes out to the wheels after it gets here. And they even have that drawn the right way. Looking at this, which way does this turn when you're going forward? Which direction? It's turning, if you're looking at the front of the engine, it turns clockwise, right? If you're sitting in the car, it's turning counterclockwise because you're facing the other way. That's what I'm always telling you guys about taking out brake caliper bolts. You got to turn the bolt the way you want it to go, right? Sure. If you want it to go away from you, you got to turn it, screw it away from you. But anyway, it's just a little aside there. The components that make up the differential are like this. Now we saw this a couple of days ago, didn't we? Now we didn't take them all the way apart, and that's what this right here is. That's a differential. I've held it up many a time. You can see that. And that actually came out of a front wheel drive. It's not very big. Yeah, but this little, you remember this right here, McBride, that pin that had to slide out so that we could push those axles in and take the C-clips off and get them out and all that? Well, on your front wheel drive, you got that little old spring ring that whenever you shove them in there, they click in. Then you got to pop them out, kind of like you had to pop them out on that car you're pulling the transmission out of. The differential is supported by tapered roller bearings. That's what they look like. You've seen those before. Remember we packed some the other day on Gene's truck, right? The differential also has thrust washers that are located beneath the pinion side gears. And so there's a lot of times, you know, when you're putting these things back together, you're basically supposed to make sure that you get that preload right on those gears. And you basically would put shims between the center part of that bearing and that carrier to make it right. And there's a way you check it with depth micrometers and all that kind of stuff, whatever. Okay, differential action is required when driving straight ahead. They're just rolling. They're basically, when you're driving straight ahead, it's just doing like this. And there's not any gear action at all. The gears don't start acting like rolling against each other until you're turning. And that's the only time that happens
So
there.
one wheel can turn faster than the other?
Yeah, that's right. That's necessary. Even those little remote control cars that you see that you drive around with your remote control, if you tear the rear end apart on one of them, it's got those same kind of gears in it. You know, it's really something. And during diagnosis, you got to remember the pinion and the side gears rotate independently of the carrier during turns. One of the things I thought was peculiar about these on this rear wheel drive stuff is we had a Ford pickup in here, the 98 model, that had busted up these spider gears that was in here. And we bought a set of spider gears, and it was $65 for a new set of spider gears in those days. And they actually had positive traction. It had that spring in between the actual gears. It was a booger bear getting it in and out of there. But anyway, got all that done, built it back up. He got him going for, you know, I don't remember what it was. The oil cost almost as much as the gears because the oil was real expensive. But a Chevrolet, just like it, costs, the gears cost $500 or $600. 10 times as much. And if you look at them, they don't look any different. I don't know how much you are for a dye.
Cheaper.
Input and output shaft assemblies. The input shaft of a manual transaxle transfers crankshaft rotation. See, here's where your clutch goes. Now, most of the time, a transaxle won't have a pilot on the end. It'll just be sticking straight out there. Along its length, there's a drive gears for all the different gear ratios. Now, you're going to notice that this gear, this synchronizer is on that shaft, and then you got two synchronizers on those two shafts. See that? They're not on the same shaft. Now, this particular one here, because it's got fifth and reverse, it's basically got one back there behind these, you know, the center housing. See them bearings? This type rides on the input shaft the same way the speed gears of manual transmission ride on the output shaft. All right, now, see this right here, your engine is here. Basically, this connects to the engine, not that. I put that arrow in a bad place. But we got all the shift collars are centered in neutral right here, except that one is not in here. That's actually supposed to be in neutral. I don't think it is. Maybe it is. Hard to tell in a picture. But now this is in neutral, and that's in neutral. The way it's done it. See how this is spinning all the time, but on this one here, basically you're just going straight through and nothing's being transmitted down this way, so everything's just sitting there. All right, here's your input and output shaft assembly. Some of the gears are cut directly on the shaft. Others are used synchronizers are separate. Now, some of these gears, when you're taking it apart, you can just take a snap ring off and pull them off. Some of them will come off after you take other parts off. Some of them, you have to press off of there with a special tool. And so it's just really, you know, it's different. And Eddie was talking about some of those guys down there. And it's kind of like automatic transmissions up here. You know, I can get somebody started on an automatic transmission, and they'll tear it down, and then they'll start putting it back together. And if I don't actually set aside time for them to put it back together, they'll let it lay there and take apart from then on, and they won't ever touch it again, you know, if it's somebody that's not particularly dedicated. Of course, I know that you guys aren't that way, you know, but I have had that. Anyway, Eddie was saying you can explain how all this stuff's worked, but when they have to work really hard to get those gears off those shafts and everything, they cry and walk away. They just walk away. We don't like people crying and walking away around here, do we? It's not good. It's not for lazy wimps. Here's right here your differential. See how I put that in there? You know how hard it was to do that? You know, to build that slide. Look here. To make that thing materialize.
Ew.
Like that. See? Pretty good stuff. You know, that was tough to make it do that. But anyway, this is how the differential connects to the front wheel drive. See, comes in from the engine, goes through whichever shafts are engaged. This right here is your ring gear, and that's, your pinion gear. That's your ring gear. And then of course our other gears. All right, the input and output shaft assemblies. A manual transmission transfers power to the differential of the selected gear on the basic transaxle output shaft zone. The first, second, fifth, and reverse gears right on the shaft that are engaged through 1, 2, or 5 reverse synchronizers respectively. Now some of them have got a synchronized reverse. If reverse gear is a helical cut gear, it'll be synchronized. If it's a spur gear, it won't be. That's why on some of these manual transmissions, when you're putting it in reverse, you gotta, you know, let off the clutch for a second, let it move those gears a little for them to drop in. Doesn't mean there's anything wrong with it. And you're gonna hear some gear rollover noise. You know, it's not really, like people used to complain when they had a brand new pickup truck. If they had a manual transmission, they didn't like the noise they'd hear when the engine was running. But you're gonna hear those gears, you know, moving in there, whatever, even if there's nothing wrong with it. 2 types of reverse idler gears. That's the one that's synchronized because it's helical cut. And this one here's a spur, and it's basically not helical cut. It's a sliding type that's engaged by a fork. That's what that transaxle over there has got on it. When it's engaged, the reverse idler gear meshes between the spur cut gears, and basically the outside of the first gear synchronizer will have teeth on it, and the spur gear will mesh with those, adds another gear to the train, and it goes backwards. That's how that works. And adding that gear to the train, the output is reversed. So when reverse is selected on the synchronizer, that's a really good picture right there. The synchronizer up pressed against the reverse blocking ring, which is pressed, the blocking ring. What the blocking ring does, it's cone shaped on the inside, and it's usually got some, what do you call it, lines, or you know, that are cut in there, kind of like a tread on a tire, or it may have a lining in there. And what it's designed to do is go against the cone on the synchronizer that it's going against, and it slows. I mean, it actually makes the speed of that thing match the one that's going through there. All right, the rod and clevis linkage uses a rod that connects to the shift rails inside the transaxle. Sometimes you got shift linkages made like that. Most of the time it's not. It's cable driven most of the time, which is like this right here. And you might notice they'll have your cables color coded. You notice how they're white and black on there, you know, so that you won't hook them up backwards. Now it's really easy. One time we had a Toyota Corolla here that we used to pull the transmission out of and put it back in, and somebody messed up one of the shift cables hooking them up backwards or something, and the shift cable for that Toyota was $125 for a replacement shift cable. Shift cables aren't cheap, even for an automatic. The shift cable, you know, we see this, you know, one's a shift cable, one's a selector cable. So the shift cable will be the one that actually puts it in the gears. The selector cable is the one that goes back and forth between your first, second, third, fourth, and fifth. See that? All right. And then you got this stuff right here, the way it's hooked up, you know. And you kind of, this is not as complicated as it looks, really. Shift linkages. Inside the transmission, there's this little part right here, you know, where you go in through your regular gears. You can kind of see that it vaguely looks like your gear shift pattern, and you can, you know, watch what that does. The most important thing is getting it to do this. Let's watch this happen. Watch. We're going to change gears now. All right, you see that? Watch again. Watch it. See how it's happening? One more time. You see it again? Got that?
One more time. One more time for the hub. Okay.
You get it?
I believe so. There you go.
All right then. All right. What gear is that? Don't put anything on your paper yet. What gear is that?
That's second.
That's first.
Okay. What about that one?
Second.
What about that?
Third. Fourth. No, that's reverse.
No, third and fourth would be their own, right? Third and fourth.
Fourth is straight lockup.
That's
No,
on
not on this one, but
That's on this one.
you're thinking about a manual
That's
transmission.
fourth.
Whenever you got fourth on one of these, this gear and that gear are the same size. But it's still got to go out here. How can you have straight lockup from here to here?
Well, you can't, never mind. I got confused. You're right.
Figure radio material got confused. All right. See this? Now we got,
So what is that?
That's fourth.
that was fourth because this gear, you notice how you're starting out with a little gear pulling a big gear, and that's going to be your first. And then you got a slightly bigger gear pulling a slightly smaller gear, and that's your second. And then you got a slightly bigger gear pulling a, you know, slightly smaller gear there. And finally, both the gears are the same size and all that. And then you've got a bigger gear pulling a smaller gear, and that's your fifth gear. And then there's your reverse, because you notice that this is going backwards now. See, let me go back, let me back up. Look at the direction the arrow's going, see? See that? First, second, third, fourth, fifth, reverse. Fifth, fourth, third, second, first. Neutral.
Neutral
First,
straight
second,
lockup.
third, fourth, fifth, reverse. You getting it?
Isn't
Yep.
these like one synchronizer is a 1-2 synchronizer, first, second gear, and 3-4 synchronizer, 3-4?
Exactly. There you go. Now let's mix up the gears and see what you know. But we're gonna turn on the light.
Why there's 7?
Huh? Did you start riding already?
No, not yet.
Did you put your name on there?
Yeah.
Well, that's a good thing. All right. Which gear is this? Don't say it out loud, just write it down. Which gear is this? Which gear is that? What's that? They're not in order, they're mixed up. What's that? Make sure you hide your paper. Which gear is that? Which gear is that?
Oh, your boy got 100.
That's the
Go to
easiest test
that
I've ever
second
done.
first.
Huh?
Go to that second one real quick.
The second one?
Yeah, the second question. No, serious.
That's the easiest quiz I ever took.
Oh, okay,
No,
no, I'll
last
send them.
semester.
You're good. My bad. You're good.
Finally, I get
That-
100.
I know, finally I get 100. I mean, this is like the easiest quiz I learned all this last semester.
Yep. Well, you know, you remember how you were beating your head against the wall last semester and absolutely could not get it for.
I did beat my head against the wall.
Yeah,
I
yeah.
did.
Yeah, but this, I mean, the thing about it is I keep refining this to make it a little, see, this is what you're supposed to do, you're supposed to make it simple so people can learn it.
Hey, you.
Without
you copied off- you got the
being
same
bored,
answers.
silly and turning it into a skeleton. Trade papers, let's see how you did. We got time.
Nick
Everybody
copied
got
off,
100.
Nick copied off and got the same answers.
Let's hope they're not wrong.
I did notice that there was times whenever two buddies would be sitting next to each other for some reason, they would miss all the same questions, you know, I mean, notice that, so. All right, let's see this. What's that?
First,
What's that?
neutral,
What's that?
third,
What's that?
reverse,
What's that?
second,
What's that?
fourth,
What's that?
fifth.
Very good.
Ninth.
Huh? You got it, huh?
Everybody got 100.
Don't you just like that? Ain't that wonderful?
Overdrive.
Well, I'm sure Nicholas is happy.
Put on the paper for you.
Ah.
There you go. That's it.
They know these.